Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of my students. So now we move to the third topic for syllabus at Math KSSM Form 4. So in this video you are going to learn chapter 3 System of Equation. So we are focusing on subtopic 3.1 System of Linear Equation in 3 Variables. Okay, 3.1 System of linear equation in 3 variables. So our learning standard for today, by the end of this video, you should be able to describe system of linear equation in 3 variables. And then you should be able to solve system of linear equation in 3 variables. And lastly, you should also be able to solve the problems involving system of linear equation in 3 variables. Okay, describe system of linear equation in 3 variables. Okay, now please have a look at the prices of the packages offered by a cinema in the advertisement on the right. So how do you determine the price of one ticket, one bottle of drink and one bucket of popcorn? So here there are 3 types of packages. So the first one we can see there are 1 ticket, 1 bottle of drink and 2 bucket of popcorn. And second package, we have 2 tickets, 2 bottle of drinks and 1 bucket of popcorn. And lastly, we have 3 tickets, 3 bottle of drinks and 2 bucket of popcorn. Okay, so the 3 equation can be formed using the variable x, y and z to represent the prices of 1 ticket, 1 bottle of drink and 1 bucket of popcorn respectively. So the prices of 1 ticket refer to the variable x. The prices for the 1 bottle of drink refer to variable y, and lastly 1 bucket of popcorn refer to variable z. Okay, so here we can see the first one, okay, x. Since there are only 1 ticket, so 1 ticket x plus 1 bottle of drink y plus 2 bucket of popcorn z, 2z is equal to 13 ringgit. So you don't have to write RM here. Okay, and then since we have 2 ticket, so 2x plus 2 bottle of drink, 2y plus z is equal to 17 ringgit. And lastly, we have 3 ticket, so 3x plus 3y plus 2z, 2 bucket of popcorn is equal to 27 ringgit. So this is how we represent the prices of the prices of ticket, bottle and drink, okay, into linear equation. Okay, so this linear equation form are known as system of linear equation in 3 variables. So in lower form you only learn in 2 variable x and y. So now 3 variables, we add another variable which is z. A system of linear equation refers to the presence of at least 2 linear equations which contain the same set of variables. So here the variables is x, y and z. Okay, so all of 3 equations contain the same set of variables. The general form of a linear equation in 3 variables can be written as follows. So ax plus by plus cz is equal to d, where a, b and c are not equal to 0. Okay, if a 0 means x 0. So here we will only left for by plus zz. So 2 variable here. That's why a, b and c cannot be 0. Okay, flashback. A linear equation is an equation where the power of the variable is 1. So there are no power at x, y and z. If the power is 2, it becomes quadratic equation. So linear equation, the highest power should be 1. Let's see how system of linear equation in 3 variables can be expressed in 3-dimensional plane. Okay, you can try this activity by scanning this QR code or go to this link. So this is the result or this screenshot. Okay, GeoGebra software. So you can see there are three axes here. The green color, the green line here, it represent y-axis. The red color, red line here represent x-axis, and the blue line, vertical line here represent z-axis. Okay, a system of linear equation in three variables has three axes, namely the x-axis, y-axis, and z-axis. Okay, previously you know linear equation in two variables only has two axis, which is x-axis and y-axis. So a linear equation in three variables, now you have addition of z-axis. Okay, all three linear equations form a plane on each axis. Okay, in general, a linear equation in two variables can be written in the form of ax plus by is equal to c. So this is for two variables where a, b, and c are constant. Geometrically, when a linear equation in two variables is sketched on a plane, it will form a straight line as shown in diagram 1a. Okay, this is diagram 1a. Meanwhile, linear equation in three variables can be written in the form of ax plus by plus cz equal to d, where a, b, c, and d are constant. When sketched, a three-dimensional plane will be formed as shown in diagram 1b here. So, there is addition of z-axis here. Okay, this is for linear equation in three variables, while this one is for linear equation in two variables. Okay, example 1. Describe whether the following equation are system of linear equation in three variables or not. Okay, for question A, so we have three equation here. 2x plus 4y minus z is equal to 10, and then we have x plus y is equal to 10z square, and then we have 5y minus z minus 2 is equal to 3. Okay, and this is three equation for B. Okay, let's check the solution. Okay, for A, no, because there is an equation in which the highest power of the variable is 2. Here, you can see that the second equation, okay, even though we have variable x, y, and z, but for z, the highest power is 2. Okay, remember that linear equation should be, the power of each variable should be 1 only. Okay, and for B, yes, because all three equations have three variables, which is P, Q, and R, okay, of the power of 1. Okay, so you can check P, Q, and R. Okay, second one also, if we multiply this one, it's become 2P plus 12R plus 7Q is equal to 0. And then we have 10R plus P. If we bring Q to the left, it becomes 10R plus P minus 5Q equal to 0. So, all consists of three variables, which the highest power is 1. Okay, so now you please try self-practice 3.1. Okay, question number 1 and question number 2. Okay, the first one, form linear equation in three variables. Okay, you can refer previous example. And number 2, explain whether these three sets are system of linear equation in three variables or not. Okay, and give reason. Okay, you can check your answer here. Okay, solve system of linear equation in three variables. Okay, the solution to system of linear equation in three variables, there are three. Okay, the first one is one solution where the plane intersect at only one point. Okay, and then we have infinite solution where the plane intersect along a straight line. And lastly, no solution if the plane do not intersect at any point. System of linear equation in three variables can be solved by finding the values of all variables so that they satisfy all three linear equations. So if we have variable x, y, and z, means that you have to find the value of x, the value of y, and the value of z to solve the linear equation. Okay, so the method to solve the system of linear equation in three variables are the elimination and substitution method. Okay, so the step for solving system of linear equation in three variables through elimination and substitution method are similar to the method for solving simultaneous equation in two variables, okay, which you have learned during lower form. Okay, so it's similar. You have to recall how to do elimination and substitution method. Okay, and then you will know how to solve the system of linear equation in three variables. Okay, let's flashback. Okay, for simultaneous linear equation in two variables, when we have both line intersecting, so means that there is a unique solution. If we have a line that is parallel, means there is no solution. And lastly, if we have both lines overlapping to each other, means there are infinite solution. Overlapping means line tu bertindih antara satu sama lain. Okay. Okay, solve the following system of linear equation using the elimination method. Okay, so now we have three equation here. First one, second one, and third one. Okay, solution. Choose any two equation first. So let's say this is the equation number 1 and this is equation number 2. I only use these two equation first. Okay, so remember, if you want to do elimination method, means that you have to eliminate one of the variable. So here, if you check both of these two equation, none of the variable have the same coefficient. Okay, for x, okay, let's say for x, this one is 4, this one is 2, this one is 3, negative 3y, this y, and this one z, 1z, this is 3z. So if you want to eliminate one of the variables, so you have to make the coefficient of one of the variable is same. Okay, so let's say okay, so I want to make the variable x same to the first equation. Okay, so multiply all of these equation, okay, all of the variable with 2. So it become 4x plus 2y plus 6z is equal to 0. So if you have, you already have the same coefficient for x, now you can eliminate the variable x by subtracting 1 from 3. Okay, so this one become equation number 3. Okay, this one lah, when you have multiplied by 2. Okay, so 3 minus 1 or 1 minus 3 also can. So in this example, the equation number 3 here subtract by equation number 1. Okay, so 4x, okay, 4x minus 4x become 0. Okay, so 2y minus with negative 3y, so it becomes 5y. And then 6z, you minus with z, become 5z. Okay, 0 minus with negative 10 becomes 10. Okay, so this is labeled as equation number 4. Okay, equation number 4. Can. And then choose another two set of equation. Okay, so here I choose 2x, okay, here lah. Okay, equation 2x plus y plus 3z is equal to 0, and this one. So equation number 5 and equation number 6. Okay, similar, you have to eliminate one of the variables. Okay, let's say I want to eliminate variable x. So this one, you have to multiply with 2. So I write it here. So equation number 5, 2x plus y plus 3z is equal to 0. And this one, if I already, equation number 6, if I multiply, it becomes negative 2x plus 4y minus 10z is equal to 34. Okay, if you want to eliminate x, you cannot use subtraction. Okay, if you minus 2 minus 2x, it becomes 4x. Means that the variable x not eliminated. So if you want to eliminate variable x, so means that the operation here should be plus. Okay, so 2 plus negative x becomes 0. Y plus 4y become 5y. 3z plus minus 10z become negative 7z. 0 minus 0 plus 34 becomes 34. Okay, so here 5y plus 7z is equal to 34. So this is equation number 8. Okay, so solve for z. So okay, so now you have equation number 8, and previously this one, equation number 5 plus with equation number 7. Okay, so it become equation number 8 here. And then here, if you compare with this two, okay, just now you have 5y plus 5z is equal to 10, and now you have 5y minus 7z is equal to 34. So you can eliminate one of the variable, which is variable y. Okay, here if you want to solve this one, okay, 5, okay, you can since the coefficient for y is already the same, so you can use subtraction. Let's say 4 minus 8, so 5y minus 5y plus 5z is equal to 10, and then you have 5y minus 7z is equal to 34. So I use operation subtraction. So 5 minus 5 becomes 0. 5 minus 7z become 12z. Okay, so 10 minus 34 become negative 24. So that's how you get here. Okay, so z, you get negative 2. Then you already solve one of the variable, which is variable z. So you still have another two variable, which is variable y and variable x. Okay, so you can substitute variable z into equation number 4 or number 8. Since equation number 4, you have variable y and z only, no x here. Or number 8, you have y and z only, no x. So you can solve the value of y. Okay, so let's say I choose equation number 8. So 5y minus 7z, z is negative 2, become 30 is equal to 34, and then you will get y is equal to 4. If you already get the value of y here and the value of z, so you can use any equation, okay, whether this one, the first one, the second one, okay, or the third one, to substitute the value of y and z, and you can solve the value of x. Okay, let's say here I use equation number 1. Okay, so you have 4x minus 3y. So y is 4 plus z. Z is negative 2 is equal to negative 10. So x is equal to 1. So now you have 3 values, which is x, y, and z. So the solution, x is equal to 1, y is equal to 4, and z is equal to negative 2 are the solution to this system of linear equation using the elimination method. Okay, so you can check your answer using calculator. So this is the 3 equation just now. So you can check your answer using calculator, scientific calculator. Press menu and then move down twice, and then press 1 for simultaneous linear equation. The number of variable is 3, and key in all the coefficient. So the screen will show s is equal to 1, okay, y is equal to 4, and z is equal to -2. Okay. Example 3. Solve the following system of linear equation using the substitution method. Substitution maksudnya penggantian. Okay, still you have 3 linear equation here. 3x minus y minus z is equal to -120, y minus 2z is equal to 30, x plus y plus z is equal to 180. So the solution. First, you label this one as equation number 1, equation number 2, and equation number 3. And then, so this one, for equation number 1, so you have, since the left hand side you have all 3 variables, so you have to make sure that one of the variable as the subject. So in this case, I want to make z as the subject. Okay, so z is equal to, so you move 3x and y, so here become z only. So okay, move to the right hand side. Okay, so you will get negative z is equal to -120 minus 3x plus y. So z is equal to 120 plus 3x minus y. Okay, or you can write here 3x minus y plus 120. Okay, similar, just the same. Okay, and then substitute this one, I label as number 4. Substitute 4 into equation number 2 here. So z here. So you have to substitute z, this one, into this one. Okay, so y minus 2z. So this one is actually z from equation number 1 is equal to 30. So substitute this one, okay, into this one. So y minus 2 in bracket is equal to 30. So expand this one. So it will become y minus 6x plus 2, y minus 240 is equal to 30. And then you will express y in terms of x. So now you only left variable y and x only. Okay, this is equation number 5. Okay, so now you not use the equation number 3 yet, but you have z and you have y here. So substitute y and z. Okay, here. So now here, this is for y, and the green color, this one is z. Okay, substitute z into here and y into here. Okay, using equation number 3. Okay, that's why x plus y, the yellow color, becomes 90 plus 2x. This one is actually y plus z. Z is actually 3x minus y plus 120 here. Okay, but since here if you see z, we have y here, so I don't want to write this y. Okay, so this one, this is actually, okay, x plus y plus z is equal to 180. So here z is actually from 3x minus y plus 120. Okay, so this is z, but here y, you already have 90 plus 2x. So that's why it becomes like this, x plus y, 90 plus 2x, and then this one is actually y. Okay, 3x minus y plus 120 is equal to 180. So now in this equation, all variables no longer have y. We don't have z anymore. We only have variable x. So you can solve the value, one of the value, which is value of x. So expand this one. So you will get x is equal to 15. And then after that, you can solve the value of y and z. Okay, substitute x is equal to 15 into equation number 5. See in here, in equation number 5 here, you only have x, you don't have z. So you can solve the value of y. So 90 plus 2x. Okay, x is 15. So y is equal to 120. Okay, and then you can solve for z. Okay, you can use this equation, these three equation, whether this one or this one, or whatever equation, you can still get the answer. Okay, in this one, I want to use equation number 3. Okay, x plus y plus z is equal to 180. So x is 15, y is 120, and z is equal to 180. So z, solve this one, we'll get z is equal to 45. So x is equal to 15, y is equal to 120, and z is equal to 45 are the solution to this system of linear equation. Okay, solve the following system of linear equation. So in this question, it doesn't state whether you have to use elimination or substitution method. So you can choose whatever method that you feel comfortable. So in this question, I want to use elimination method. So here. Okay, so this is equation number 1, equation number 2, and equation number 3. So if you observe here, equation number 3, we don't have variable x. We only have variable y and variable z. Okay, so the variable for the first two equation, we have x. So we need to eliminate x. So how to eliminate x? Let's see. The coefficient is not same, so you have to make sure that you have to make the coefficient for the first one becomes 2 or negative 2. Okay, so the first one multiply with 2. Okay, let's say this one. First one multiply with 2, so it becomes 2x minus 2y plus 6z is equal to 6. And then this one is negative 2x plus 2y minus 6z is equal to 6. Okay, if you want to eliminate, you cannot use subtraction. Okay, if you subtract, becomes 4x, so it not eliminate, so you have to use operation plus. Okay, so if you plus this one, it becomes 0. Negative 2 plus 2 becomes 0. 6 plus negative 6 becomes 0. Equal to 12. Here, you can see that 0 plus 0 plus 0 is equal to 12. 0 is equal to 12. Thus, this system of linear equation has no solution. Okay, as 0 is not equal to 12. So, we don't have the value for x, y, and z. Okay, next, example 5. Solve the following system of linear equation. So this is equation number 1, equation number 2, and equation number 3. Okay, let's say I want to do elimination method. So as usual, we have to eliminate one of the variable here, 3 and 5. So it's not easy to make the coefficient for x the same. And similar to, let's say I want to solve 1 and 2. Okay, similar to this one, y 5y and negative 2y. So it's hard to make the coefficients the same. So what I can do, I want to make coefficient for z. It's the same. 2 become 4. So I need to multiply. I need to multiply equation number 1 with 2. So I will get 6x plus 10y minus 4z is equal to 26. So this is actually equation number 1. Okay, and equation number 2 just now we have negative 5x minus 2y minus 4z is equal to 20. Okay, so how to eliminate these two equation? If you use plus, let's say I want to use plus. So negative 4 plus negative 4z here, it becomes negative 8. So you cannot use plus here. So you have to use minus. Okay. So 6 minus 5x become 11x. 10 minus 2y become plus 12y. Negative 4z minus become plus, so 0. Okay, 26 minus 20 become 6. So this is equation number 5. Okay, now we left with variable x and y. So let's do another two set of equation. Okay, equation number 1 and equation number 3. Okay, since if you observe equation number 1, the coefficient for z is already the same. So negative 2 and plus. So let's say I write it here. 3x plus 5y minus 2z is equal to 13. And equation number 3, we have negative 14x minus 17y plus 2z is equal to negative 19. So which operation should I use? Either addition or subtraction. So let's say if I use subtraction here, so it become, for z it will become negative for z, so I have to use plus. Okay, so 3 plus with negative 14, okay, you will get negative 11x. 5 plus negative 17, you will get negative 12y. Okay, negative 2z plus 2z becomes 0. 13 plus negative 19 is equal to negative 6. So this is equation number 6. So if you compare equation number 6 here, let's see, equation number 6 here and equation number 5 here, so we are left with variable x and variable y. So we can eliminate these two variable. We can do elimination. We can do elimination method for these two equation number 5 and equation number 6. So if you observe the variable for x and variable for y, the coefficient is already the same. Okay, let's say I use operation addition. So I write it here. We have equation number 5, 11x plus 12y is equal to 6. And equation number 6, we have negative 11x minus 12y is equal to negative 6. Let's say I use addition. If I use subtraction, it does not eliminate variable x, so I use addition. So 11 plus negative 11 becomes 0. 12 plus negative 12 becomes 0. 6 plus negative 6 becomes 0. So here 0 is equal to 0. So this system of linear equation has infinite solution because 0 is equal to 0. So now we have covered 3 types of solution for a system of linear equation in 3 variables. Okay, so please try self practice 3.2. Okay, solve this following system of linear equation using elimination method, and then please do substitution method. Okay, so you can check your answer. And lastly, solve problem involving system of linear equation in 3 variable. Usually, we want to solve the problem. They will give question with long situation. Okay, just like this. Okay, so Tommy has 3 condominium units. Type A with 1 bedroom, type B with 2 bedroom, and type C with 3 bedroom. Okay, all 3 condominium units are rented, and the total rent received by Tommy, okay, is RM 1,240 per day. Okay, Tommy needs to save 10% for type A, 20% for type B, and 30% for type C. Okay, so the total daily saving is 276. The rent for type C unit, okay, this is another information. The rent for the type C unit is twice for the type A unit. What is the daily rent for each condominium unit owned by Tommy? So you have to make sure you convert this long situation into 3 linear equation with 3 variables. Okay, so understand the problem. So I already highlight. Okay, the total rent is 1,240 per day here, and this is the saving, maintenance charge 10%, 20%, and 30%, and then the total daily saving is 276. Okay, and lastly, the rent for the type C unit is twice the rent for the type A unit. Okay, you already understand the problem. So plan the strategy. Okay, so as I already told you that you have to form 3 equations, okay, which involve the total daily rent, total daily saving, okay, here total daily saving, and lastly the rent for type C unit. There are 3 equations from this situation. Okay, now we want to implement the strategy. So means that you have to form 3 linear equation with 3 variables from the situation just now. Okay, so for the first equation, you can get from the statement that mentioned the total rent. So total rent for unit A, B, and C is 1,240 ringgit. So this is for equation number 1. Okay, this is for equation number 1. The equation number 2, you can get from the sentence that mentioned the saving. So 10% for unit A. 10% means if we convert to decimal, becomes 0.1A. Okay, 20% for unit B means that 0.2B. And 30% for unit C is 0.3C. So the total daily saving is 276. So this is for second equation. And the third equation you can get from the sentence that say that the rent for unit C is twice from the type A unit. So C is equal to 2A. So this is equation number 3. So these 3 equation is actually from the situation just now. So I want to do elimination method. Okay, let's say I want to do elimination method here. So this one for I want to solve number 1 and number 2. So the coefficient we have to make it the same. So this one 0.1. So equation number 2 I convert into multiply with 10 first, so that it becomes the whole number. So we get this one 0.1 times A, we will get A. 0 plus with 0.2, get 2B plus 3C is equal to 2760. So this is equation from number 2. So this is, let's say this is equation number 4. Okay, and then
I want to solve with the equation number 1. So let's say I want to solve, I want to eliminate B. Okay, you can eliminate A or you can eliminate C. But now I want to show I want to eliminate B. So here, B, the coefficient is 1. So if I want to eliminate B, I will have to convert equation number 1 as 2. Multiply with 2. Okay, so it becomes 2A plus 2B plus 2C is equal to 2480. Okay, so I want to eliminate B, so subtract. A minus 2A, negative A. 2B minus 2B, 0. 3C minus 2C plus C. 2760 minus 2480, it becomes 280. So here is equation number 6. Okay, since this one become equation number 5 when we multiply with 2. Okay, just now why I choose to eliminate B, because if you observe the equation for equation number 3 here, the variable is only variable C and A. There is no variable B. That's why for equation number 1 and 2 just now, I eliminate B, so that we will only left with variable C and variable A. It is easier to solve the variable C and A using the equation number 3 letter. So that's why I eliminate B just now. Okay, so now the equation left with A and C. This is equation number 6. So if you observe here, C is equal to A, equation number 3. So you can substitute C into my new equation, which is equation number 6. Okay, so here negative A plus C. C is 2A is equal to 280. So you can solve here. So 2A minus A is equal to 280. So now you have the value for A. Okay, so if you want to solve for another variable, which is, it is easier for you to solve variable C from equation number 3 here. Okay, since you already have the value of A. So C is equal to 2A. So C is equal to 2 times 280. So you will get 560 for value of C. So now you already have the value for A and the value of C. You can substitute into equation number 1, equation number 2. Okay, but it's easier if you substitute this value into equation number 1. Okay, substitute the value here, 280A. This one is 560 is the value of C into equation number 1. So you will get B is equal to 400. So you already solve the rent for A condominium, B condominium and C condominium. So 280 is actually for unit A, RM 280. Okay, RM 280 for type A. For type B, so 400. And lastly, for type C is 560. So this is the solution. Okay, you can check your answer for value of A, B and C. Okay, from the statement that mentioned that the total rent, which is A plus B plus C, is 1240. 1240 already mentioned in equation number 1. Okay, or you can also check the value for equation number 2, which is 10% for unit A. Okay, 10% for unit A, 20% for unit B, and 30% for unit C. So the total daily saving is 276. So this already mentioned in the question. So this is for you to check the answer. So the answer just now is here. Okay, this is the answer, 280 ringgit, 400 and 560 ringgit. Okay, please do the solving problem question sub-practice 3.3, question number 1 only. Okay, so and then you can check your answer letter here. Okay, before you get the answer, the value for P, Q, and R, make sure that you make the three equation with three variable. Without those three equation, you cannot get the answer and you cannot get mark at all. Okay, 0 mark for if you don't get the equation. So don't skip the solution just now. Okay, I already teach you, so please refer the previous example to do this kind of question. Okay, conclusion, what we have learned for today. Okay, first we solve system of linear equation in three variable using elimination method and substitution method. So this method is similar to the linear equation in two variable. And then we also learn types of solution. There are three types of solution for system of linear equation in three variables. So the first one is infinite solution, and second one, no solution, and lastly, one solution. Okay, that's all for today. Thank you. So in the next class, you are going to learn new subtopic 3.2, simultaneous equation involving one linear equation and one non-linear equation. So that's all from me. Bye bye.